Here's a motivating example for our class from the field of pharmacokinetics. Pharmacokinetics is the science of how medicines move around in the body, or what the body does to medicines, or what the medicines do to the body. Really interesting stuff, pretty important. So let's suppose you just have a patient who's getting an intravenous infusion of some medicine. We aren't going to be super realistic here and specify a medicine, but let's just say it's some important medicine. And they get infused at a constant rate of medicine, like 100 milligrams per hour. And then once it's in the body, the medicine decays or gets absorbed or something. And that happens at a proportional rate, proportional to the current amount in the body of 16%. So together, these tell you how the medicine amount is changing in the body, the rate of change. And then we want to use that to predict how much medicine is in the body at the next time step. So let's write what our rate of change is here in kind of English. We don't have to have Excel understand it at the currently. So the rate of change would be, well, every time that time step that goes by would be 100 new milligrams per hour. And then some decays, so we're going to subtract 16% times the current amount of medicine in the body. So that tells us the rate of change, and then how do we use that to compute the new amount in the body? Well, we've got our calculus style prediction equation from our previous demonstration, which is the new amount equals the current amount plus the rate of change times delta t. Move that over. So just from that, you can do all the calculations here. So you might pause the video and do all the calculations. Ready? 3, 2, 1, pause. Okay, welcome back from pause. Here's how I'm going to do this. So I need to figure out the change rate. So I said it's 100. Now instead of typing 100 here, I should really refer to this cell, because I want to be able to just change that one cell and have all the calculations change, rather than having to change a number inside a formula. And I'm going to deliberately make a mistake here. We'll come back to it in a sec. And then we'll say minus the 16% times however much is in the body right now. And does that 100 make sense there? Well, 16% of 0 is 0, and then we're adding medicine at 100 milligrams per hour. So I think 100 makes sense. We should fill in delta t. That would be the next value of the time minus the current value of the time. And we will double click to fill down on that. And then let's calculate the new amount in the body. That's using our calculus prediction equation. New amount equals current amount plus rate of change times delta t. It might be a little tricky to figure out which delta t should I use, the one on the previous row or the one on this row. It depends on how delta t is calculated. Is it from this row looking forward one row to the future? What is the future from this row's point of view? And that's how we're doing it. So that's what we want to do here. And now I could fill that down. And it looks like, well, it's not changing anymore, but that's because it's using rate of change values that are blank. So I might say, well, let's fill that down too. And that does not seem to have worked as well as I would have hoped. So let's figure out what's going on there. Let's double click on that. Well, it's saying take the current value here, which is what we want, minus the, D6 is actually, we meant it to be 100, but now it's looking at the 16 instead of the 100. And then D7, we wanted that to be looking at the 16, but now it's looking one row down at a cell that's full of words, and Excel doesn't know how to do calculations with words. So it just says, oh, I don't know what kind of numeric value you expect there. It's all words to me. So the problem is, up here we had said, look at these two cells. And then when we filled down, it tried to slide those references down. What I need to do instead is tell it, don't change these cell references when we slide down. So we do that by putting a $sign in front of the part of the reference that you don't want to change. I don't want that row 5 to change. And notice I'm doing this on my very first formula here, not the second one. And here the reference to D6, I don't want the 6 to change when I drag stuff up and down. The C10, I do want to change to update to C11, C12, etc. Oh, I just hit escape accidentally. I didn't mean to do that. So I need to put my dollar signs in here again. Okay, so that's still 100, but then if I fill that down, now on the next row it is referring to this current amount in the body on the new row, but still referring to those. So I'm apparently getting reasonable calculations here. All right, and the next thing to do is to graph it. So I had already generated up to time 10 here. Let me show you a quick trick in Excel. If I click on a cell and then use my cursor keys, I can move up or down or left or right. Nobody's surprised with that. If I hold down the Shift key and press the cursor up key, then it highlights as it moves. Or if I press cursor down, if I press cursor right or cursor left, it highlights as it moves around. If I press the Control key, hold down Control and press the down arrow, it will jump to the bottom of the column, the bottom of whatever's filled in the column, or at least it'll jump to almost the next blank cell. If I did it again accidentally, I'd press Control and go all the way down. That goes to the bottom of the spreadsheet, row 1,000,000 something, which is not what I wanted to do. So I'm going to press Control and the up key. And then if I press Control up again, it goes to basically where the next blank cell is. So that's Control up and Control down. Control right will jump to as far right as it can until the next blank cell. So now if I combine Shift and Control, it should highlight and jump around. So I'm going to click here, then I'm going to hold Shift and Control, and then I'm going to press cursor right and then cursor down. You don't have to press them simultaneously. You can just hold down Shift and Control, and then at your leisure press cursor right and then press cursor down, and it has highlighted that big block, and I didn't have to drag and drag and drag while I highlighted. And then I'm going to insert scatter plot. Let's use dots with straight connectors. And is this what we expected? Delta t seems pretty much constant, except the last delta t here is a number that doesn't make any sense, so we will click on that and hit the delete button. The amount in the body seems to be increasing. The change rate of the amount in the body seems to be decreasing. It's kind of a pain sometimes to have your graph way down at the bottom here, so I'm going to click on it, click on a blank spot, and hit cut, and then scroll up, click somewhere reasonable, and hit paste. So now my graph is right near the top where all the interesting stuff is. So the question is, the amount in the body seems to be increasing, but it's in a curved kind of fashion. Will it keep increasing forever? Will it increase to infinity? Are those different questions? What can we do to figure this out? So that is the intravenous infusion problem. We set up a formula for the rate of change. In the car problem, we just said, well, the acceleration is -7 meters per second squared, and we didn't have to think about it as a formula. It didn't depend on how much of something else was going on in the problem. And then we use but here the rate of change does depend on the current kind of y value. And then we use the calculus prediction equation to say how much is in the body now based on how much was in the body. So that's our IV infusion problem.